Hello, and welcome to Beyond Thinking, where we share and discuss about space exploration and humankind. Join us and keep watching. But first, if you like this content, consider liking and subscribing to hear more about Beyond Thinking. The odd species that inhabited the planet prior to the dinosaur era is our topic today. What types of organisms inhabited the Earth billions of years ago? We prefer to think of Earth as the blue marble, a stable, temperate, hospitable planet that's constantly changing and evolving. Earth is a place we call home, which would have been completely different at other points in history if we zoomed out on the celestial timeline. Let's imagine what Earth would have looked like during its evolution billions of years ago. Let's begin with the earliest period. 4.5 billion years ago. The Earth is currently essentially a hot, molten rock ball. Since the Earth hasn't yet developed a magnetic field, most of the hydrogen and helium in its thin atmosphere are swept away by the solar wind. As a result, the young planet receives little shielding from the sun's cosmic rays, making it a radiation hotspot. A process known as accretion occurs when asteroids and comets strike Earth constantly, adding to its mass. Just picture a large ball of chewing gum that you continuously add new wads of gum to. Therefore, the young Earth is not only warm, but it is also expanding. In a catastrophic event that occurred, a protoplanet collided with the Earth, creating the Moon as a result. The seeds of transformation are still sprouting despite these dismal beginnings. Water, a unique substance that will be vital to Earth's history, is traveling on board the approaching asteroids. Although not all of Earth's water comes from these meteors, many of them, according to scientists, do. This hypothesis states that these meteors are struck by hydrogen ions from the solar wind, which then eject oxygen atoms from beneath their surfaces, creating water. Most of the water on the young planet is seeded by these regular impacts. Then, when the planet cools, lighter substances like water ascend to the planet's surface and heavier elements sink to its center. Other gases like carbon dioxide, ammonia, and more water vapor are released into the atmosphere during volcanic eruptions. All of this accumulated water vapor will eventually result in the development of the oceans and the planet's developed atmosphere. Next, we explore the Earth when it became pale orange dot. 2.5 billion years ago. Earth has a magnetic field and a solid crust that have preserved its methane-rich atmosphere, which resembles Saturn's Titan in appearance and has a unique light orange haze. The immense oceans of liquid water on Earth were also created by rainfall. The Moon is enormous and frighteningly close than it is right now. The Moon has been steadily drifting away from Earth for the past 2.5 billion years and is currently doing so at a rate of 3.8 milliliters each year. It will take several billion years until this 3.8 milliliter per year drift stops. The Moon was much closer 2 billion years ago, and this proximity caused the ocean's tidal pressures to be much stronger. Earth must have resembled a desolate dream world, far more akin to an observed Salvador Dali painting than the bustling planet we know today. The cause of the orange haze was identified as photosynthesizing bacteria known as cyanobacteria by certain blue-green water samples. Life has evolved on Earth. The Great Oxidation is an occurrence that resulted from populations of these ancient bacteria living in shallow seawater, releasing oxygen into the atmosphere. The result of this transition is that the ozone layer, which shields life on Earth from the most destructive impacts of solar radiation, has been created. In addition, the bacteria are creating stromatolites, unique rock formations like those found in Shark Bay, Western Australia. By binding sediment grains with biofilms or microbial slime, cyanobacteria created stromatolites, one of the biosignatures that should be looked for on distant planets according to astrobiologists. They're producing nutrition from carbon dioxide and water using solar energy, and as a result, they're sprinkling oxygen into the atmosphere. Then the Earth changed into a snowball. Cryogenian period, 650 million years ago. According to this hypothesis, the entire Earth is frozen solid. Imagine the Pleistocene Ice Age of the past, only much colder. Half of the Earth's oceans and its whole surface are entirely frozen solid. The equator has frigid temperatures that are comparable to those to present-day Antarctica. Some possibilities as to what caused this decline in global temperatures include a significant volcanic eruption that sent ash into the atmosphere, a significant decrease in greenhouse gases as a result of photosynthesizing living forms, and Milankovitch cycles. This global cooling was most likely increased by a number of variables. A single supercontinent, dubbed Pannotia, centered on the South Pole, lies beneath all of this glacial ice. However, it's difficult to distinguish between land and water due to the extensive glacier cover. There was once molten rock on top of the immense never-ending glaciers in the frozen landscape. The Earth's young life might have been wiped out at first by the severe climate, but it has shown to be extremely robust. Cyanobacteria are still present in the water, possibly gathered near hot hydrothermal vents. Additionally, there are recently evolved microbial life forms like red algae. Although complex multicellular life is still elusive, the fact that life has so to endure the planet's hardest freezing episode is evidence of its resilience. We now proceed to the next period. Devonian period, 360 million years ago. The entire globe was thawed, and it is now typically warmer. Tropical sea surface temperatures are predicted to drop between 30 and 21 degrees Celsius, a change that's correlated with declining CO2 levels because of rising plant growth. The supercontinent has fragmented into several continents, the largest of which is Gondwana, which spans much of the southern hemisphere and the South Pole. Gondwana is a sizable continent that includes a significant portion of what is now Africa, South America, Antarctica, Australia, and India. The Cambrian explosion, a massive increase in biological diversity, has flooded the seas with a variety of complex species, is the most significant alteration in life. Trilobites, clam-like brachiopods, and sophisticated marine vertebrates like fish are now abundant in the oceans. Dunkleosteus, a large armored fish 10 meters in length, and Titanictus, another monster with a penchant for smaller prey, are two of the more menacing species. The once arid continental crust has undergone a major transformation due to plants. Unchecked growth of vegetation results in vast, dense forests that have built up a topsoil layer of stable, nutrient-rich oil. Given that they are vascular plants, like some conifers and modern ferns, trees would appear extremely bizarre. Additionally, there is a massive prototaxite fungus that resembles a tree and is around 8 meters tall. These strange tree-like formations most likely represent the fruiting bodies of much larger, non-preserved underground animals. A few marine cultures have even developed limbs and are starting to walk on land, like the cute four-legged vertebrae known as the ichthyostega, which can move through swampy environments due to its strong limbs and lungs. Cretaceous period, 145 to 66 million years ago. After the Devonian period, the Earth showed signs of natural diversity and a temperate climate. The once molten planet now resembles the blue marble that we are familiar with to some extent. Big changes have yet to occur though. When marine life is decimated by a global extinction event, the adapting land animals gradually become more complex. Once more, temperatures plummet, bringing about the late Paleozoic Ice Age before rising once more to higher levels. With the emergence of new amphibian species and a few enormous reptiles known as dinosaurs, complex life has continued to evolve. Following the demise of the dinosaurs, flowering plants took over, continuing a process that began during the Cretaceous and is still ongoing today. But anything more than 25 kilograms on land became extinct. What was left basically contained the seeds of the present. Tens of millions of years after the extinction of the dinosaurs, the first modern humans, also known as Homo sapiens, first appeared around 300,000 years ago. Before spreading to what is now Europe and Asia and eventually settling in other regions of the world, it is assumed that the earliest people resided in Africa. If you have any thoughts on the ideas discussed in this video, please leave a comment below. If you enjoy this content and would like to see more on space exploration and humankind, please like this video and subscribe for more videos on Beyond Thinking. Thank you and have a beyonder nice day.